Welcome to math class. We are continuing on in our Math 9 course. We are working on our geometry project. We're building cardboard castles. By now we've actually finished building the castles, and we are going to be moving on to actually figure out how we calculate the perimeter and area of our castles based off of the measurements that we've taken and created throughout this project. So what we're going to look at in this video today is I'm going to quickly show you how we can do perimeter and area for our shapes. We're going to start off with perimeter. Perimeter is basically a fancy word for the outside of an object. The way I always like to explain it is basically if your object was a fence, how much fencing would you need to cover that area? That's what perimeter is. Perimeter is very, very simple for triangles and squares and rectangles. All I really have to do, let's go ahead and say this is 5, and this is, we'll use centimeters, 2 centimeters. All I have to do for my perimeter is I have to side plus side plus side plus side, right? I know that this side right here is 5 centimeters. That means that this one's also going to be 5 centimeters. Since this one is 2 over here, that means this one's also going to be 2. So my perimeter is simply 5 plus 5 plus 2 plus 2. Gives me 10 plus 4. My perimeter is 14 centimeters. Easy peasy. You should be able to figure that out. All we have to do is add up the sides. Since our shapes aren't perfect squares, I'll show you a little bit later in the video how we're going to deal with that particular little problem, but at least understand the idea of a perimeter is basically just figuring out how long are all of our sides. For squares and rectangles, very easy. For triangles, it's not that much harder. I still have to do the same thing. I just have less sides. P equals side plus side plus side. So let's say I've got 4 and 5 here. We'll use centimeters again. Since I know that this side is 4 centimeters, I can also assume that this side is 4 centimeters, at least in this particular triangle. So my perimeter is going to equal 4 plus 4 plus 5, which gives me 8 plus 5. The perimeter of my triangle is 13 centimeters. Easy peasy. Now the tricky one. Now we have to get into formulas. How do we figure out the perimeter of a circle? And perimeter of a circle actually has its own fancy word, circumference. Oh, my spelling is losing it. Circumference. Our circumference equals pi times the diameter of the circle. Pi is a unique and special number within the mathematical world. It is specifically related to circles. I don't want to get into the details of that during this particular lesson, but you should recognize the pi symbol off of your calculator. You're going to need a calculator, and particularly a scientific calculator that has that particular symbol on it. You will have a whole bunch of trouble trying to do this without a pi function on your calculator. So make sure you bring one of those to class when we do this. So our formula for circumference is simply pi times the diameter of a circle. The diameter of the circle is the total length across of a circle. Let's go ahead and say that this one is 10 centimeters. The radius of a circle is from the center point of the circle, and it's the distance out to the nearest edge. Radius is always half of the diameter of a circle. So this radius here would be 5 centimeters. We don't really need it too badly right now, but it's a good piece of information to know. So if we're going to figure out how much the circumference of our circle is, then we are going to simply follow our formula. So C equals pi times the diameter of our circle, which we know is 10 centimeters. I go ahead and just punch that into my calculator. So I go 10 times pi, and I get an answer of 31.41. We'll say we just go to 2 decimal places here. 31.41 centimeters. So that means that the distance around this circle is 31.41 centimeters. But Mr. Waldo, when we were designing our castles, we designed it so that our walls were intersecting parts of the circle. So they don't wind up being a nice perfect circle. It look like this. Or it would look, most people's designs look like they had a circle like this and their walls run right into the middle of it. Now there is detailed ways that we can figure out exactly how much perimeter we're dealing with, but for the purposes of this project, all I want you to decide is if your wall is hitting, if your walls are intersecting your circle and this outside piece here, you need to decide whether that is 1/2 of your total size of your circle, 1/3 of the total size of your circle, or 1/4. My guess for this one is this is about half of a circle that is facing the outside part of my castle. If that's so, I'm just going to go ahead and pretend that this is the same as my last circle. This is actually my 10 centimeter circle. So what I'm going to do is, if I have a pretty typical castle design where I've got a wall, tower, wall, tower, wall, tower, tower, wall. If we have something like that, what you need to do for your perimeter is you need to add up this side, this side, this side, and this side. If you did this easy, you kept all of your towers the same size. And so what you're going to do at this point is you have all of your sides. Let's say that that is, well, I don't know, 50 centimeters once you've added up all your sides. What you're going to do at this point is figure out which size of circle it is, and you're going to take that same number we had up here, and you're simply going to divide it by 2, 3, or 4, depending on whichever size of circle you think that you're going to use. Most people, I imagine, are going to be looking at a half of a circle. So let me scroll down and give myself just a little bit more room to work with. Bump this out of the way. So what that means is I take my 31.41. I'm going to go ahead and say that this is half of a circle that I have facing the outside. So I'm going to divide this by 2, and I get an answer of, where's my calculator? There it is. 31.41 divided by 2. So I get an answer of 15.705. So what that means is that for each one of my towers, the outside part of it is 15.705. Since I've got 4 towers, I can just go ahead and multiply this number by 4. Multiply by 4. And I'm going to get 62.82 centimeters. If all of my sides added together was 50 centimeters, plus my circles were all 62.82 centimeters, now all I have to do is combine them together. So I wind up getting 112.82 centimeters. I did that in my head really quick, so let me just double check. 62.82, let's add 50. What do we get? 112.82. So that is how we figure out the perimeter of sort of a funky castle shape like this. I need to add up all of my sides. Even if you had a triangular shaped one, you do the same thing. I just need to add up all my sides. And then I need to figure out, do I have half a circle, a third of a circle, or a quarter of a circle facing the outside? And I can calculate that. There's a few steps involved, but the math is not overly difficult. Let your calculator do the heavy lifting. So that's how we deal with perimeter. But how do we deal with area? Let me extend this so I don't have to keep bumping my screen. Area is not that much more difficult as long as you can follow dead mass and follow a formula. So the area for squares and rectangles is length times width. So let's say that this is our 5 centimeter and 2 centimeter box again. What that means, my formula is simply going to be area equals length times width. So in this case, it is 5 times 2. So my area equals 10 centimeters. Since I'm multiplying centimeters by centimeters, I'm going to finish up with centimeters squared. Area is always going to have a unit squared. That's always going to be the form that your answer is in. So remember, for squares and rectangles, area is your length times your width. Pretty straightforward. What about triangles? Triangles is not very much harder at all. The formula for this is 1/2 of your base times your height. The measurements you need when measuring a triangle is you're going to need to know how long your base is. So what did we say this one was last time we did it? Okay. We'll say that this is 5 centimeters, okay, across the base. I didn't measure this. We'll go ahead and say that this is 3 centimeters tall. Okay. All we have to do here is plug in our specific numbers into our formula. So what I have is area equals 1/2. I'm going to leave that alone for now. I'm going to plug in my base and my height. So area equals 1/2 of 5 times 3, which is 15. 1/2 times 15 is the same as 15 divided by 2. So my area, let me give it a little space, my area is going to equal 7.5 centimeters squared. Very simple, very easy. As long as I know my measurements for the triangles, this is a pretty straightforward formula to follow. Okay. And the very last one we're going to need is the area of a circle. So the formula for area of a circle, area equals pi, and then it's our radius squared. So remember, we talked about our circle in the example being 10 centimeters, but then the radius was actually 5 centimeters. We are going to be using our radius number in this particular equation. So our area is going to equal pi times 5 squared. Remembering our order of operations, I know that I have to deal with exponents before I can deal with multiplication. So my pi is going to be timesing 25. 5 squared equals 25. I can go ahead and punch that into my calculator. 25 times pi gives me an answer of 78.54 centimeters squared. Okay, so that is how our formula for area of a circle works. It's very straightforward. But Mr. Waldo, I've got all these crazy shapes. How am I going to combine this into one area? Very simple. Let's go back to our same basic castle shape that I think most people are using for their project. So normally what I would actually do, sorry, let me back up a step. Area is the footprint. How much space are you taking up on the surface of the earth with the structure that you're building? That's what area is. Right? So what we need to look at is how much area is each one of these spots covering. Now there's a couple sort of more complicated or funky in mathematical things we can do here to figure out exactly the fact that inside these little corners here, we are actually going to be almost double counting because we're going to be doing part of our square as well as part of our circle. But that's okay. What we're looking for in this project is we're just trying to get used to working with area and working with perimeter a little bit, getting used to seeing these formulas. So what I want to do in a situation like this is I'm simply going to add up all of my shapes. Now, looking at this, I know it's not a perfect square, but I'm going to take these side lengths. Let's say that this side length was, I don't know, 30 centimeters, and this one was 40 centimeters. We'll use these same circles. We'll say that these were our 10 centimeter circles, okay, so that I don't have to recalculate all of those. All I simply want you to do is figure out the area of the square and the area of your circles. So area, sorry, I'm not going to put circles up there. Area equals pi r squared. So you need to figure out this. You're going to have, obviously, 4 circles, so I'm going to times that total number by 4. I don't really need you to worry about taking off pieces so that we're double counting or anything. I just want you to get used to calculating out the area of a square or triangle if that's what shape you made your castle. Say you're doing something like this, you could figure out the area of this particular triangle, which would be A equals 1/2 the base times the height, and then I would just add all three of those together. So to give you a quick example of what it would look like for this particular shape, I know the area of my square. I'm going to bust off this triangle. The area of my square is 30 times 40. Okay. So what that means is 30 times 40 is going to give me 1,200 centimeters squared. We already calculated out what a 10-centimeter circle is up here. So I'm going to pull this down. So my area equals 78.54. Remember, that is one of my towers, just a single one. So I'm going to multiply this number times 4 so that I can count all four of my towers. Go ahead and use the calculator for this one too. 78.54 multiplied by 4 gives me a total of 314.16 centimeters squared. And now I'm just going to add those two numbers together in order to get my final answer of 1,514.16 centimeters squared. So that is all I need you to do for these. Find whatever shape is actually taking up a footprint on the Earth, use the formulas to calculate it out, and then add them all together at the end and give me one nice big number for each shape. So that is how we're going to do that. Good luck, and I'll see you in class.